I hope you guys have had a wonderful Christmas break and that you're super excited.
And now it's time for your semester review.
Guess what? It's 2017.
Welcome back. We know you missed us over these past 2 weeks listening to our videos, and we have 2 children in here who are looking at us like we're crazy now.
Would you like to shout out hi?
Hello.
Say hi.
Okay.
We are reviewing for our semester exam. Ooh, the semester's almost over. We are halfway done with this year. Wow. So
You guys are 7.5 graders.
7th grade 7.5.
I love it. I love it.
So we're gonna review some solving equations and inequalities because we did that a long time ago. A long time ago. We will solve equations and inequalities by following the algorithm.
It's been 2
So long you
weeks.
don't remember
What's
an algorithm? It's just the process.
process.
Process. So Jake sold 4 cupcakes and an additional cake for $15 and made $30. How much did he sell each cupcake for? This is basically just, we're writing the equation. We know he sold cupcakes and we know he sold the cake for $15. We also know he spent $30
total.
$30 total. So do we know how much each cupcake cost?
No.
So is that my variable?
That's what we're looking for. That would be the variable.
That's the variable. So I'm going to do 4x plus the amount of the cake equals 30.
And see, what I would have done, I would have put 30 because I know that would be my total equals, I know that I'm going to spend 15 on a cake. Plus, I know about 4 cupcakes, but I don't know how much they were.
So many people have asked me, oh, I did it wrong.
No,
you
not
didn't
at
do it.
all.
And
This
so
is the
these are the
same
exact
thing.
same
Same
things.
thing.
So
Just
I'm really glad
flip-flopped.
that Miss Newsom
Yes.
threw that one in because they're the exact same thing. We're going to continue with this one just because that was the first one that was done.
Yeah,
But both of
course,
them are
right,
perfectly
yeah.
fine. It's
Sorry
all
I took
good.
up your space. I was just trying to show.
Hey, look at that Miss Green gave me
Oh my
more.
goodness.
So, we're gonna... Miss Green's laughing at me now. 4x plus 15 equals 30. I kind of like it this way just because I'm OCD and I like all the stuff on this side and this on this side.
Oh my
now
God,
Miss Newsom's going to
gross.
roll her eyes at me. I'm just weird that way. But again, that's perfectly fine. That's just why I set it up that way. So,
Constant.
what is my constant?
You got to eliminate your constant.
Eliminate my
first.
constant, which
It's
is my one all by itself.
not attached to the variable, but on the same side
Yes.
as the variable.
I'm going to use inverse operations. The inverse of addition is subtraction. So I'm going to subtract 15.
Yes.
Subtract 15.
Yes.
I'm even going to throw the little line down here like Miss Green does.
Whoa.
30 minus 15 is 15. And I'm left with 4x on this side because that's all that's left. Now I'm going to divide by 4. Divide by 4. X
That's not
equals... It's not pretty. It's going to be a decimal, but is that okay? Because cupcakes sometimes cost a decimal.
Yeah, it's going to be 4. No, it's going to be 3 point something. Here, let's see. What is it?
3.75?
Maybe. What is it? 15
15 divided by 4?
Yep.
Boom! I
You
was
got it.
right. $3.75 per cupcake.
That's kind of expensive for cupcakes.
That is expensive. They must be really good cupcakes.
They're those gourmet ones.
Ooh,
gourmet.
cupcakes.
Yeah.
So that's how we set up and solve an equation. For those of you who forgot,
I'm glad that you didn't forget.
I'm glad I didn't forget to.
Oh my gosh.
Did you?
What is,
I haven't heard from Green. Did you
what is-
forget?
what is happening here?
This is. Whoa! Hold on. You know what? You know what's happening? There's an imaginary number in there. It's not imaginary. It's just invisible.
Because it.
It exists, but we don't need to know it. I mean, we need to know it, but we don't need to put
Because
it in.
there's one.
There's one negative.
But
So that's a -1 times a -1/3 plus 2x equals -3.
Well, hold on. Don't we all know that a negative times a negative gives us a positive?
So that makes this +1/3 plus 2x
That looks
equals
much nicer.
-3. That is so much prettier. Whew, that was tricky. That all went away now, and it's just 1/3 because a negative times a negative is a positive. Now, oh man.
Constant.
Constant is 1/3. It's the number by itself.
And you have to be careful, guys, because we're not gonna be multiplying by the reciprocal.
No,
we're
we're
going to be
subtracting
subtracting
a third.
1/3 from both sides.
So we're subtracting 1/3 here. And so we are doing -3/1 minus
Minus-
1/3.
What do you need to have first?
Common denominator.
Oh my goodness.
So my common denominator is going to be 3. This is going to be -9/3 minus 1/3. I'm left with -8/3.
Yes, good job.
So I've got 2x equals -8/3. Whew, this was not a pretty problem.
Miss Green.
Oh, great. Now we're going to...
Yeah, now we're going to divide.
Okay, so
Miss
now we
Green
got to
was mean.
separate 2 times x by dividing
divide by
by 2
2.
on both sides.
Divide by 2. So I've got negative 8/3 divided by 2 over 1.
Wait, I thought we could
We
divide
multiply
fractions.
by the reciprocal. Negative 8/3 times
1 over 2
1 over 2
gives
equals
us 8 over
negative.
Whoa.
Negative 8 over 6.
That wasn't
Which,
bad.
no, it wasn't that bad. When you simplify that down, we are left with negative 4/3. Or 1 and 1/3.
Yep.
I
Negative
like
1 and
negative 1 and 1/3. I like 4/3 better just because I'm weird.
Merry Christmas, y'all.
Welcome back.
Welcome back.
Christmas is over.
I don't know what that is.
Start.
Christmas tree.
Oh, okay.
Rational numbers.
Rational numbers.
We're going to
throwing
be
it
going
in.
over them.
Yes. Oh my goodness. It doesn't say the actual
I
numbers.
see a bunch of letters.
So this is 1, 2, 3. Okay, so I've got 3.
3 positives.
3 positives. And I've got 1, 2, 3, 4 negative x's.
X's.
So negative 4x.
Wait, hold on. You wrote minus.
But a minus and negative, aren't they like the same thing?
Remember, you can. They're this. Whatever's in front of that number belongs to it.
Yes. So if I were to box my terms, that negative 4x would be there together.
I get it. Okay, just making sure.
Yep.
If it was positive, it would be plus 4x, but
Yes.
they're negative, so it's.
Can I write plus negative 4?
You could write
You
plus
could.
negative 4x. Do you want me to?
No.
Okay.
I just wanted to make sure.
You could write plus negative 4x, but it's the same thing as saying minus 4x.
So just on the top, I'm going to write 3 plus negative 4x, which is the exact same thing. Because technically,
You don't need that.
You're adding 2 numbers that are different, which means to subtract.
Yes.
So just wanted to.
Yes. And then we've got 1, 2, 3, 4, 5, 6, 7 negative. So I've got to put negative 7. That's a goofy looking 7. Now, what's my constant?
3.
Okay, so I'm going to subtract 3 because that is a positive. I'm not going off of this.
No.
That is not what I'm going off of. That is a positive 3.
This
so,
belongs to the 4.
yes, so that is 3 minus 3, which equals 0, which is what I'm looking for.
Right.
Subtract 3 here. Oh, man, what is
Careful.
negative 7 minus 3?
It's an even bigger negative.
Negative 10 equals, don't forget the negative. Negative
The
4x.
fraction.
I know, it's another fraction. Miss Green likes her fractions
to
today.
separate the number times.
Divide by a negative
The
4.
variable you divide.
have to do the negative. Divide by a negative 4. A negative divided by a negative is a
Positive.
positive. So we've got a positive 10 over 4. When I simplify that, it's a positive 10 over 4. 10 divided by 4 is
5 over 2.
5 over 2. Or I was getting there.
2 and 1/2.
Or 2 1/2.
There you go. Perfect.
Yep. Whew, another one. Oh, it's an inequality.
Inequalities are pretty fun. Same thing that we've been doing, solving the same way
Yes,
at least.
exact
You
same
eliminate
solving.
your constant, which is
4. And I'm going to eliminate it by inverse operations, which was subtracting. So minus 4, 6x is greater than or equal to 2.
do not change the sign. Why?
Because I didn't do anything to
We're
change
just
the sign.
subtracting 4, right.
The reason I change the sign is if I multiply or divide by a
negative. I just wanted to
Cool.
bring that up.
So I'm going to divide by 6. X is less than or equal to 1/3. And then on here, I know we've all taught you different ways to do this, but I like it the 1/3. We're going to do 2/3, and we're going to do 0. Open circle or closed circle?
It's going to be closed.
Closed because of this little
The equal
The
sign
equal
means
sign.
that value is included, so we shade it in.
Think about it. When you graph on a number line, you usually shade in the number that you're included, that you've picked. So if it's equal to, it shades it in. Now, is 0 less than or equal to 1/3?
Yes.
Okay, so
It is
could
less
be
than,
go that
so
way.
you need...
Is 2/3 less than or equal to 1/3?
No, that's larger, so it doesn't fit that
so
inequality.
I'm going to shade this way.
Less is left, or left is less.
So, there we go.
Perfect. Wow, that was a great shading.
It was a terrible shading. What are you talking
Oh,
about?
it's so pretty.
One more problem for today, and then we'll let you go. Negative 4 minus 5x is greater than negative 6. Whew. Okay.
Wow.
I know. Hey, at least it's not going to
What's
be a
the odds
fraction
it'll be
this
positive at the end?
time.
Let's
I
see.
can see it.
You can.
I can see it's
All
not
right,
a fraction.
add 4 because that's our
Inverse.
operation for our constant.
Add 4. Oh, no, it is going to be a fraction. Ah, I'm mistaken. She giggles because she did this to us. So negative 6 plus 4 is negative 2. I'm going to divide by, a negative 5. What happens when I divide by a negative?
Something happens here. Yeah.
I flip my sign. And I'm left with a positive
2 over
5. And then when I graph this, I've got 2 fifths. Let's do Miss Green's version of it. 2 fifths. Is it going to be open circle or closed?
It's going to be open.
Open because it does not include the 2 fifths.
So it doesn't include it.
Now, is 0 less than 2 fifths?
Yes.
0 is less than 2
Yes.
fifths. Is 1?
You had to think about it for a second.
Is 1 less than 2 fifths?
I think. No, 1 is not less than 2
So then
fifths.
I'm going to shade this way. And that is it. That is our review of equations and inequalities. Peace out, y'all.
Bye.